Okay, this video is going to be for all the mathematicians, math enthusiasts, and otherwise math lovers out there. Matter of fact, if you're not a math enthusiast or mathematician or math lover, then this video is probably going to be pretty boring, and so I wouldn't mind if right now you just clicked off the video and go watch something else. I don't know, go watch some cats or something like that. I really wouldn't mind, because if you don't like math, you're not going to like this video. Anyhow, for those of you who do like math, what if I told you that I could find all perfect squares without using multiplication? Using no multiplication whatsoever, only using simple addition, I could find all perfect squares. What would you say about that? Would you be impressed? Or you're probably like, okay, it sounds really good, but you want to see it, right? Okay, that's fair enough, you want to see it. I respect that. So let me go ahead and draw my chart real quick. I hope you guys could see this. I don't know how wide of an angle the camera has, but this should be far enough. So let me just draw my chart real fast. Don't mind my curvy lines. I'm not an artist by any definition. Okay, in this column right here, I don't know if you can see it because I know it's kind of small, but I'm just writing odd numbers. And in this one, I'm just going to put P and S for perfect squares. I don't feel like writing out the whole word. Okay, and then I'm just going to go ahead and write all the odd numbers, or some odd numbers right here, starting from 1, 3, 5, 7, 9. Now to start this off, I'm going to go ahead and put a 0 in this column over here, and we're just going to add 0 plus 1. Simple enough, it equals 1, right? Okay, that's your perfect square. Now take your first perfect square, the 1, and go ahead and put it over in this column. And now go ahead and add the 1 plus 3. That's 4. Okay, easy enough. That's your next perfect square. Take that, put it into this next column over here, add 4 plus 5, 9. Take that 9, bring it over here, add 9 plus 7, 16. That's your next perfect square. Take that 16, bring it over here, add 16 plus 9, 25. That's your next perfect square. Are you seeing the pattern? All you have to do, starting with 1, you take that perfect square, you put it in the subsequent column, add it to the subsequent odd number, and you get the subsequent perfect square. You do the same thing. You take that perfect square, put it over here, add it to the subsequent odd number, and you get the subsequent perfect square. And you keep going and going and going. All the way to infinity, you could get all the perfect squares. Now, I hope you're impressed. I was pretty amazed when I figured out this. But now you're probably asking, okay, well, how did you figure that out, right? That's another fair question. Let me go ahead and erase this real quick here. I was actually in math class, and the professor was going over something that I was already familiar with, so I was kind of bored, right? And so I decided to start messing around with perfect squares. I don't know why I chose perfect squares. I could have messed around with anything. I should have just doodled probably like everybody else does. Draw some stupid pictures. Anyways, so I started messing around with perfect squares. And so I figured them out in the ordinary fashion, obviously. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. I'm just figuring out the perfect squares in the ordinary fashion. 4 squared equals 16. So on and so forth. I started doing that, right? But what I like to do is I like to look for patterns in things. I like to see, is there any relation between these things? Just anything, any kind of pattern that I could find whatsoever. So I looked at 1 to 4. I was like, okay, does this go up by any certain increments? So I figured out, okay, 1 to 4, the difference between that is 3. Okay, well, what about 4 to 9? What's the difference between 4 and 9? Well, okay, that's 5. Okay, well, what's the difference between 16 and 9? Okay, that's 7. Okay, then I started to see, oh, we're going up by odd numbers. I thought that was kind of peculiar. maybe a coincidence. I'm just assuming this is a coincidence at this point, right? So I did my next perfect square, 5 squared equals 25. Okay, what's the difference between 25 and 16? Turns out to be 9. Okay, and at this point I'm starting to, notice a trend, a pattern here. Okay, let me do my next perfect square. Okay, 6 squared equals 36. Difference between 36 and 25, that's 11. I was like, these continue to go up by the subsequent odd number. So, if this is more than just a coincidence, if this is an actual pattern, then I said, okay, I'm going to stop doing the multiplication. I'm going to stop doing, say 7 squared. I'm not going to do 7 squared. I'm not going to do that. If my pattern is right, this method that I'm starting to figure out here, then the next perfect square should just be 13 more than this one, right? So 13 more than this perfect square. So I did, okay, obviously 36 plus 13, 9, 49. Sure enough, 7 squared equals 49. That's the next perfect square. And then you continue, okay, 49. And then, okay, so then the next perfect square should be 15 from that. So 49 plus 15, that's 9 times 14, 64. Sure enough, 8 squared is 64. I was totally amazed. I mean, literally my mouth dropped. Matter of fact, I almost got in trouble because I started texting people. I texted my friend and I texted a few other people. I was amazed. I was like, does anybody know about this, And I don't know, still, I call this my method, but somebody else may have this. I don't know. I want people to research, find out if anybody has figured this out. But as far as that I can tell, no one else has figured out this pattern. So I was quite impressed and I was quite happy with myself for figuring it out. But the beauty in it for me is that a lot of times people new to algebra or whatever, they don't like perfect squares. They find it hard finding perfect squares. But now with this method, with the chart that I drew earlier, you can find all the perfect squares. Forget doing all the 2 squared, 3 squared, 4 squared. Just have them do simple addition. Be like, okay, you don't like perfect squares. You don't like doing all the multiplication. Okay, just find your perfect squares using simple addition. I don't know. I was impressed. But again, I would really like to find out if anybody else has this method. I'm not trying to plagiarize. I'm not trying to take anybody else's method. If somebody else has this, I do apologize. But if not, if I invented this little method here, I don't know. I think it's pretty cool. But anyhow.